Hello everybody, topic of our presentation is sedimentology. Today we are going to talk about sedimentary rock types, origin and transport of sedimentary materials, methodology of sedimentology, and the last one is importance of sedimentary rocks.
So, what is a sedimentology? Sedimentology studies sand, mud, or silt and clay, and the various ways they are deposited. Using these studies, sedimentologists apply their understanding of modern processes to ancient rock to try to understand how it formed. Most of the rocks on Earth are sedimentary rocks, and it is in these kinds of rocks you find fossils and many of the other historical markers. Sedimentary rocks are also where petroleum deposits are found. Sedimentology is tied to stratigraphy, which studies the relationships between rock layers and how they can shift and move. This also affects where petroleum deposits can be found, as well as how the extraction of petroleum affects the sediment around the deposit.
Sedimentary rocks have four types. They are clastics, carbonates, evaporites, and chemical. The first type is clastic rocks. Clastic rocks are composed of particles derived from the weathering and erosion of precursor rocks and consist primarily of fragmental material. Clistone is clastic rock. The next one is carbonates. Carbonates are composed of various carbonate minerals precipitated by a variety of organic and inorganic processes. Typically, the majority of carbonate rocks are composed of reef. Dolomite and limestone are examples of carbonates. Evaporites. Evaporite is a water-soluble mineral sediment that result from concentration and crystallization by evaporation from an aqueous solution. There are two types of evaporite deposits. The first one is marine and the second one is non-marine. Marine, which can also be described as ocean deposits. Non-marine, which are found in standing bodies of water such as lakes. Halite and the gypsum are evaporites. The last one is chemical sedimentary rocks. Chemical sedimentary rocks, including some carbonates, are deposited by precipitation of minerals from aqueous solution. The examples of chemical sedimentary rocks are chert and juspelite.
Origin and transportation. Most sedimentary deposits are the result of transport of material as particles. Movement of detritus may be purely due to gravity, but more commonly it is the result of flow in water, air, ice, or dense mixtures of sediment and water. The interaction of the sedimentary material with the transporting media results in the formation of platforms, which may be preserved of sedimentary structures in rocks and hence provide a record of the processes occurring at the time of deposition. If the physical processes occurring in different modern environments are known, and if the sedimentary rocks are interpreted in terms of those same processes, it is possible to infer the probable environment of deposition.
Methodology of sedimentology. The methods employed by sedimentologists to gather data and evidence on the nature and depositional conditions of sedimentary rocks include several steps. The first one is measuring and describing the outcrop and distribution of the rock unit. Describing the rock formation, a formal process of documenting thickness, lithology, outcrop, distribution, contact relationships to other formations. Mapping the distribution of the rock unit or units, description of rock core drilled and extracted from wells during hydrocarbon exploration, and the sequence stratigraphy.
The next one describes the progression of rock units within a basin, also describing the lithology of the rock, petrology and the petrography, particularly measurement of texture, grain size, grain shape, sphericity, rounding, etc., sorting and composition of the sediment, analyzing the geochemistry of the rock, isotope geochemistry, including use of radiometric dating to determine the age of the rock and its affinity to source regions.
Importance of sedimentary rocks. Sedimentary rocks provide a multitude of products which modern and ancient society has come to utilize. For example, marble metamorphosed limestone rocks are used in art, architectural uses, metashale and sandstone, ceramics, industrial materials, clay, limestone, economic geology, gold, gemstone, energy, coal, oil shale, and groundwater.
In conclusion, we would like to say that sedimentology studies are important in order to understand modern processes to ancient rock and how it formed. Sedimentology research are not using only in geology, also some sedimentary rocks useful on other spheres such as art, architecture, and industrial materials.
If you would like to take more detailed information, you can link to these websites.
Thank you for your attention.